When I say y is equal to fx as a function, it should always give me first idea that this is nothing but group of some coordinates x comma y. These are few trivia facts about function. Okay, so function is nothing but a systematic group of few points, which will, when I will draw it on the graph, it will give me a certain figure. That figure can be anything, it depends on the type of function. So if it is a quadratic, it will give me a parabolic figure. If it is a log, log is also a function, it will give me this type of figure. There are various other types of functions also. So currently you should just understand this thing, that what is a function? X comma y coordinates, which are bounded by some condition in a systematic manner. So it will give me a proper shape. Okay. Next thing, when I say value of a function, value of a function, it is always y coordinate, always. Okay, when we say maximum value, minimum value, it is always y coordinate. This is also a very general mistake done by many students. Question ask value and they don't understand what is it. So they're just asking the y coordinate at what point. So they will give the condition in the question. Let's say for this particular graph, we don't have anything, but they are asking me the minimum value of the function. So you should have at least this much understanding that value means what? They are asking me the y coordinate of this very point. Okay, look at the bottom of the graph. So by some given conditions, I can get the x value that will be in the question only, and I need to get the respective y for that. That will be my minimum value of the function. Okay, x values for any function are always inputs. Okay, always input, certain values which you can put in. Okay, x value for any function are also termed as roots, particularly when I talk about quadratic function. So it will be the roots of the very quadratic equation which we will be writing it as a function. Okay, so for example, if I write y is equal to x square plus 7x plus 6. Okay, this is just a quadratic function which I have taken randomly. Now, what are the observations which you should be able to make out from here? First thing is, from your previous knowledge, you should be able to factorize it because it will always be needed. Okay, so you should be able to factorize it. That I'm not telling you because I'm assuming that everyone knows how to factorize a quadratic. Okay, then the next point of observation is, when we compare it with a general quadratic equation or general quadratic, you see A, B, C values. Okay, so the sign of A determines that what type of parabolic shape you are going to get. So there are two possibilities. Either it will be an upward parabola or it will be a downward parabola. Okay, it all depends on what is the sign of coefficient of x square. In some of the question, if you'll find written like this, 6 minus plus 7x minus x square. Okay, this is just an example. So you can see that the coefficient of x square is negative. Because of that, it will be the other one, the downward parabola. Okay, so upward parabola is when a is positive, downward parabola is when a is negative. Okay, this thing is clear. After that, when we say it is y is equal to something, so a function will always have two types of intercepts. One is called as x-axis intercept, one is called as y-axis intercept. I'll take it on the next slide. I'll explain you that with respect to this example only. So if I have y is equal to x square plus 7x plus 6, I need to find y-axis intercept. Okay, so y-axis intercept is always obtained by putting x is equal to 0. Always. And this is not only for quadratic, it is applicable for all types of functions, whatever we are going to do for 2 years. Okay, putting x is equal to 0 will give you y-axis intercept. What does it mean on the graph? Let us understand. So on the graph, when you will plot this parabola, let's say the parabola over here, okay, I'll just plot this only. So when I factorize this parabola, this quadratic equation, it will give me x plus 6 and x plus 1 as the factors. If anyone have doubt in these factors, you can ask, I can explain again. Okay, means I'll explain the whole process, how to get that. Anyone? Madison, Raghav, Rishon, Rajveer, anyone?
So just how to factorize the quadratic equation, that's what you're asking?
It is same as the 10th grade method, what you guys
Yes,
have.
sir, I know.
Okay.
No issue.
Yeah, but still, if there will be doubt in that, we will do it again when we are going to do the quadratic equation in detail. Okay.
Yes, sir.
Like we have to do it again. Quadratics is there in grade 11 also. Okay. So now just try to have a look at these two factors, x plus 6 and x plus 1. And when you will equate them to 0, I will get x is equal to -6 and -1. These are the roots of a quadratic equation. If a question asks that solve, so what you will solve? You will solve to get the x values, means you will solve to get the roots of the quadratic. Now, if I plot them on the graph tentatively, so -6 and -1 will come over here. Okay, you can see that how smartly I am drawing the graph. You don't have to draw the actual graph. You should be able to just make a rough figure. Even in exams also it is allowed. Okay. -6, -1 are the two values of x, which are the roots of quadratic. Now, what is the meaning of roots of quadratic? Roots of quadratic are also known as x-axis intercept. Okay. This is like a new thing for all of you, but you know already how to find the roots. So you know how to find the x-axis intercept. X-axis intercept will be obtained by putting y is equal to 0. Everyone try to recall the method. How do we find the root? We do like this only.
Yes,
Okay.
so then
So
S and
regular
P and then we
procedure.
get it.
Okay. So regular procedure means we are just putting y is equal to 0 and what we are getting x-axis intercept. If you will compare both the intercepts, you will see that they are obtained in the similar manner. If it is y-axis intercept, you will put x is equal to 0 and vice versa. So no need to learn both. Be smart, learn the way it is being written and learn any one thing. Okay. So I can say that x-axis intercepts are these roots. So from here, at least you should have a rough idea about intercept, that intercept are the values on the axis where the graph is cutting the axis. Okay. So now this graph is also cutting y-axis at a certain point. It will cut. Okay. This is the point. How to find this point? So the procedure is already written. Y-axis intercept is obtained by putting x is equal to 0. If you do that in this equation, you will get y is equal to 6. And it is quite evident from the graph also that this point can be potentially 0, 6. Okay, it is fairly possible. So 0, 6 is the y-axis intercept, how it is obtained, and what is the intercept. Everything should be clear, whatever is there on the slide. If there's any doubt to anyone, you can ask now. Okay, is it clear? Everything is clear to everyone?
Yes, sir.
So
So
these are
basically it
the
just means
roots.
that,
These are
so it
the
just means that,
uh,
it just means that if we put x is equal to 0, then we'll find the exact place of y, and if we put y is equal to 0, we'll find the exact place of x. That's what this means, right?
yes, yes. So in
Okay.
short, I can also say that intercept is what? What is an intercept? So intercept is like the point where the graph is cutting the axis. Like you can see that -6 is a point where it is cutting the axis. -1 is a point where it is cutting the axis. Similarly, 6 is a point where it is cutting the axis. Now it is cutting which axis? That will be the name of the intercept given. If it is cutting the y-axis, intentionally I'm using the word cutting. It can also be used as intersecting. Okay, I'm not using sophisticated words. You just try to understand the concept. Words are not important. Okay, so where it will cut the axis, that will be called as intercept. The same logic is applied even in a straight line also. Okay. So these are the things which we should know. Then now we have seen that how to draw the graph. You can see that without actually plotting it, we have plotted the graph. Okay. Tentatively, this is the correct graph, and this much is only required for your exams also. You need not do it exactly. Now, the next thing which you should be able to identify from the graph is minimum or maximum value. Now, this comes from some common sense. Like when we have this case, a greater than 0. So this graph will always have a minimum value. It can never have a maximum value. Reason is obvious. It is going up to a certain level and then it is coming back. So up to which level it is going, it will have a minimum value. And when I say value of a function, I hope you guys know that what I'm talking about. I'm talking about the y coordinate. Okay, how to get the x coordinate, that we are coming on to it very soon. Similarly, the other case will only have the maximum value. It cannot have the minimum value. Now someone can say that, sir, we don't know where it is going. Okay, so there will be some minimum. Okay, it is going infinitely anywhere down, no? So there will be some minimum. So how we can say that it do not have any minimum value? Reason for that is we don't know till where it is going. Okay, and because of that, the minimum value is not defined. It can go infinitely. That's why we'll never talk about minimum value. Okay, so in both the cases, according to the cases, they will ask you minimum or maximum value. Now, how we have to obtain it? So all you need to do is you should get the x coordinate somehow. Okay, all quadratic graphs are always symmetric. I repeat, they are always symmetric. Now, what is the meaning of that? If I just draw a line from the center, I can say that this line is actually dividing the graph into two equal halves. Okay, so the graphs are always symmetric. When I'm talking about quadratic, it means that these two x values can be used to get the midpoint, and the same midpoint will be this x value. So all you need to do is find the midpoint of -6 and -1 on the x-axis. Now for that, also in 10th grade, it was there in CBSE as well as IB. Up to 10th grade, you have done it somewhere. To get the midpoint, the formula is x1 plus x2 by 2, y1 plus y2 by 2. In CBSE, it was there by section formula. So in section formula, when it is 1:1 section, we get this formula. Okay. Have you guys seen it, Rajveer and Madison? This formula before?
Yes, sir.
So this gives me the midpoint. Okay. This is not a good idea. Okay. So let me just do it like this. So this gives me a midpoint. Okay. And
Yes,
I
sir.
need to just get the x value of it. So -6 minus 1 is -7. -7 by 2 is my x coordinate. I need to get the y coordinate. How will I get the y coordinate? Can anyone guess?
So you can put x as 0. Oh no.
If you will put x as 0, then you will get this. You will not get the
Yeah.
y coordinate. Okay, try to remember the first statement which I gave about all the functions. All the functions are nothing but x comma y coordinates written in a structured manner or written in a proper systematic manner or drawn in a systematic manner. Okay, so every point on this graph is nothing but x comma y coordinate. And every point on this graph will satisfy the equation of the quadratic which they have given over here. It means if you will put -7 by 2 in this function, I'll do it over here. Y is equal to x square plus 7x plus 6. If I will put -7 by 2 in this equation, I will get the y value, which will be this y value, and that will be my answer. So that is how we get the minimum or maximum value. To get the maximum also, procedure is same. Okay, you can do tens of different questions, but the concept, whatever we have discussed over here, it will be same. There will not be anything beyond this. So is it clear?
Wait, so sir, to find the midpoint, we do x1 plus x2 divided by 2, y1 plus y2 divided by 2.
Yes.
And then to get the minimum point, we use the x1 value, I mean like the x value into the equation, and then we find the
Yeah.
minimum or maximum.
Yes.
Okay.
So it should be logically clear that if I say a quadratic graph, so each point on this graph it should be satisfied by this equation. Each point, I mean to say x comma y. So if I have this x comma y, which is over here, so the x value, if I insert, I should get a y value, and that y value will be the minimum value. So it is very logical if you understand like this. Okay, please don't try to learn anything from here, because high chances you will do something else if you will try to learn it. If logically it is not clear to anyone, or if anyone have any confusion regarding how this point is in this, you can ask. Okay, now the next point which we have
Can
to,
you explain again how we get y, sir?
how do we get y? We have to just put this coordinate x value minus 7 by 2 over here.
Oh, yeah.
Okay, and solve. And when we will solve, we'll get y only, because we always write function as y is equal to something. So you put x,
Yes,
you
sir.
get y. So this particular y will be the minimum value.
Yes, sir.
Why it is the minimum value? Because it is corresponding to that x value, which is x coordinate of the minimum. Clear?
Yes, sir, it's clear.
Now in quadratic, I have uploaded one video on YouTube recently only, discriminant of a quadratic. Okay. I will repeat the same content which I have uploaded in the video. Okay. But yeah, later on, if you want, you can even watch that.
Sir, I think I know what it is. Is it
Okay.
the root of b square minus 4ac?
Yes, it is only b square minus 4ac.
Yeah. Okay. Yeah.
Okay. So from where the concept of discriminant came into picture, so let us understand that and why it is useful, why we have to do it. So we know that to find the value of x, we have this formula. Okay. And in this formula, we have a square root term. And on the square root, there is always a condition that square root should always be positive. It should be always positive. It can't be negative, but it can be 0. Okay. I repeat, square root can be 0 or it can be positive, but it can't be negative. I'll just write it down over here. So any square root will always be greater than or equal to 0. Okay. So that is exactly will decide, or that is exactly the origin of the concept of discriminant. Okay. Now what we are doing, we are actually trying to find the sign of this term b square minus 4ac, which is lying in the root, in the square root, and that is, we are calling it as discriminant. Okay. Discriminant is helping us to discriminate between the nature of roots, whether the roots are real or they are imaginary. Whether they are real or imaginary. Real means, like if it is positive root or 0 root, then we will get a certain value of x which will be real, which we can call it as roots. Okay, but imaginary roots will be obtained when the value of d is negative. So from here also, I will just bifurcate it into two different parts, d greater than equal to 0 and d negative. So when there is d negative, we will end it over there, because till now we haven't learned how to solve complex numbers. Okay, but it is not that we cannot solve it further. That is where we have to learn complex number. It will come this year only. So d greater than equal to 0 can be further divided into d greater than 0 and d equal to 0. D greater than 0 is a condition when there will be two distinct roots. Like we saw in that example, there were two values of x which we were getting. So that is called as distinct, means two different values. And D is equal to 0 is a condition of equal roots. Now, what is the meaning of equal roots? So if you look at that formula, if your whole square root term will be 0, you'll be left with only minus b upon 2a. Now there will be only one value of x. So in that case, we write that value of x as two repeated roots. Example, if I have x minus 2 whole square, when you will open it, it will also be a quadratic equation only. But when you will factorize it, you will get x minus 2 only. Okay, so we rather tend to write like this, x minus 2, x minus 2. And from here, I will get two values, which will be repeated roots. Their value will be same, but they are treated as repeated root. And that is a condition of D is equal to 0. So till here, is it clear to everyone?
Yes, sir.
Any doubt?
So
till
what
here?
does discriminant mean exactly?
Discriminant is this value which will determine that what will be the nature of roots, whether it will be real or it will be imaginary. Like we say, we are discriminating between people. So like this discriminant is discriminating between the type of roots, whether it will be real or it will be imaginary. So I can
So
also
doesn't
write
it also say if like how many points are touching the x-axis?
exactly. That is
Yeah,
what we are going to see next.
yes, sir.
Okay. So with respect
Yeah.
to these conditions, now I'll show you the graph, that how they actually look on the graph. That is the real thing which I wanted to show you. So these are the conditions on paper. Now we'll understand them on the graph. Okay. So if we sum up all the conditions, then I have categorized quadratic into whether it will be a greater than 0 or a less than 0. In a less than 0, I have a condition d greater than 0, d equal to 0, and d negative. Okay, there will be a type of quadratic in which there can be three types of discriminant which can exist. It is fairly possible. Okay, the same thing can happen with a negative case. So it will have d positive, d equal to 0, and d less than 0. Okay, is this thing clear? So graphically, there can be 6 types of quadratic equations which we can get. Okay, please don't get into that number. Understand the condition, how it is being done. Okay, it is very easy. When I will do everything, you will find it very easy. But yeah, it is too much information. So you may feel bit unusual, it may feel, okay, because lots of things are coming very fast. So I'll draw rough graphs now. When it is d greater than 0 means this is a case of distinct roots. Okay, just focus what I say, you'll understand everything. Distinct roots means on the x-axis, the quadratic will look like this. It will cut the x-axis at 2 points. I'm just drawing rough graphs, so just try to understand from these graphs. Okay, then the next case is d equal to 0. So d equal to 0 will be like, okay, I can use this only. So it will be just touching the x-axis. It will not cut the x-axis because we have only 1 point as the x value. And when it is d greater than 0, less than 0, then in that case, it will neither cut or touch the x-axis. So this is a real proof that this particular quadratic equation have no solution, have no roots. Because what is the meaning of roots? There should be certain x values. And which x values? Where it cuts the axis. So this graph is not cutting the x-axis, means it will have no real roots. Are these 3 graphs clear? Okay, anyone have any doubt? Raghav,
No, sir.
all good?
So we did this like in detail in CBSE, so this is something I'm very clear with.
Okay, but we didn't do the graphs.
So we did the graphs as well, right? If it touches at 2 points, that means 2 distinct points. That will always be.
We have done graphs?
Yes, so we did it along with the graphs, but this wasn't a major focus on the exams. But the sir did, you also did explain this.
Okay, I I don't remember whether we have done the graphs because it is not there in the portion. I may have explained, but for
Yes,
CBSE
sir.
portion, it is not there.
Yes, sir. We didn't ask in the exam, but you did explain. I remember that. Even the teacher explained. Yes, sir.
Okay. The next three cases for A negative. So A negative are the types of parabola which are downward parabola. So it is very obvious that when it is D positive means there will be two distinct roots. So the graph will be like this. Okay, it will cut the x-axis at two different points. When it is D equal to 0. Okay, so D equal to 0 means the graph will be like this. And when it is D negative means the graph will be like this. Okay, so these are the simplest way with which we can understand all six cases. All six cases is a summary of whatever we have done till now in quadratic. Okay, so till here, if everything is fine, none of the question can go beyond this. Okay, the type of questions, the way they will ask, it may differ, but the concept will be from these only. Okay. Okay, so if it is clear, let me. So at least everyone knows that log is like, it is written like this, y is equal to log of x. Okay, from where everything originated. So the origin of log lies in exponential forms. Now, since log is also learned as a function, so I can say that exponential function. Okay, try to understand everything properly. When I say y is equal to a to the power x, this is called as an exponential function. What is the meaning of an exponent? So exponent is any term which is written like this. We should have certain base and we should have certain power. This power is also called as index. Okay, so from this word index only, the plural was indices or indices. The name, the chapter which you have done, laws of exponents, everything, these were just revolving around this only. Okay, so now this is treated as a function, and we discussed just few minutes before only that when we say a function is nothing but x comma y coordinates in a certain sophisticated manner. Okay, so when I draw the graph of this, I will get it in this form. This is a graph of exponential rise. Okay, you just put the values of x, as you will put positive values of x overall, a being a constant. A can be any constant, you can take 2, 10, whatever. Okay, so it will rise like this. Okay, now the point is log is just one more representation of an exponential function. To be precise, log is inverse of exponential function. Okay, now why we have to learn log as a function? Why can't we work directly with exponential forms only? That is the main point from where you'll understand that why log is important. Okay, so let's say if I have a number 10 to the power 25. Okay, when I will store this number in a computer or in any machine, if I feed this number, it will be literally stored in the form of 100000025. Okay, that is how the things work. It will not be stored in the form of 10 to the power 25 unless machine is like you have just installed that scientific notation in the inputs. Okay, if not, it will be stored in this form only, but ultimately the value will be this only. Okay, try to understand that. Now, when we talk about any device, any machine, okay, it is all about space. It is all about memory. Okay, let's say if you buy any mobile, whatever gadgets we are buying, so we always look for how much RAM it has. Then only we can say that it will be faster or it will be slow, whatever. Okay, so the point is, since it is all about memory, so we have to make sure that we store everything in our machines in such a way that it should take minimum memory. Okay, you have to learn it from the perspective of a developer, not from the perspective of a user. Like right now, you are a user. You're just using a calculator or a laptop. Now just imagine in future if you will do something in technical field, and somehow if you have to develop something which other users will use. So you have to always think in such a manner that I have to use minimum, I have to make sure that my app should be of minimum space. Like a photo editing app with all the features, if you can get it in 15 MB, why would someone download an app of 100 MB? This is what I'm trying to explain over here. Okay. It is all about features only. No? So if I give you all the features in 15 MB, you will download this app only for sure. Okay. So that is where the log comes into action. If I want to store this value as the whole value, it will take more space.
Yes,
When I
sir.
store the same value in log, now this is a background thing. Okay, the layman will not understand. They will store 10 to the power 25 only, but in the background, it will be stored in the log as a function, and log will store this value only as 25. Okay, this is not a magic. This is how the logs, the concept of log are there. Okay, I'll tell you how it is 25, and when it will be retrieved back for the user. Okay, it will retrieve back once again in the form of 10 to the power 25. So as a user, I need this only, no, that I have written 10 to the power 25. Whenever I want it back, it should show me this only. But in between, what we are doing, we have inserted a function, and because of that, we have stored the big value 10 to the power 25 only as 25 with the help of log function. So this is a very small example which may seems very useless, but when it is about space and memory, this is a very big thing, because of which log is very important to study. Okay, it will be used in lots of, like when we write algorithms. Okay, so in algorithms ultimately there are functions. Don't take it in that way that I will not be doing computer science engineering or I'll not be writing. In some or the other way, you guys will be connected with all these things, not directly but indirectly. Like I hate programming. Okay, I'm saying my point. Because of that, I didn't continue with that field. Okay, I'm also from the software engineering background, but I didn't completed that because I didn't continue with that because I am not fascinated with coding. I don't like it. But the maths used in coding is this only. The functions used in coding is this only. Whether you do coding or not, you should understand the functions. Okay. Okay. Coming to how this will be stored as 25, let us understand that. Okay. So I have y is equal to log of x to the base a. Okay. Try to understand this. A log function will always have base. Like an exponent always have base. Try to correlate this with y is equal to a to the power x. Only correlation, not exact. Okay. So this exponent function has a base. Similarly, the log will have a base. Okay. How this is read? This is read as logarithm of x at the base a. Okay. Log of x at the base a is y. Base will be constant. Because of that, sometimes you will find it like nothing is written over there. If nothing is written over there, it will be treated as a default base. Default bases are usually 10 or e. Now what is e? So e is a constant whose value is 2.71. Okay, value is not required, but you should just understand that e is just a constant. Okay, so when log is defined to the base e, this is called as natural logarithm, which is also written as ln. In log, if you have read somewhere written y is equal to ln x, ln stands for log natural. So when it is natural logarithm, it is always to the base e. Okay, so this is how we write log. This is how we pronounce, means we just speak it out like this. Okay, so you should just learn this first, and now let us see that how we can get that, means how we can apply this thing in the log. Okay, So since this is a function, y is equal to log x to the base a, there is one more way to just do the reverse process of it. Now, what is the reverse process? That reverse process is called as anti-log. Okay. So let me write down the definition of log, then we will understand anti-log. So power to which base must be raised. It is very easy to learn because there is a rhyme in this. Okay. Power to which base must be raised to get the number. This is a bookish definition. Okay. We'll try to make some sense out of it. Power to which base must be raised. First point is this base. What is the base?
A.
Base is A. Okay. So what I'll do, I'll raise A to the base something, base of something. Okay. Now to get the number, power to which base must be raised to get the number. Now what is the number?
X.
We are finding logarithm of a number. Logarithm of a number. So with that, can I say that x is a number for which I am talking about?
Yes.
Okay. Power to which base must be raised to get the number. I am finding logarithm of x. I'll write it down over here. So x is equal to power to which. Power to which means what? Because ultimately log of something is giving me a value. So I have to raise the power to that value to get the number. Look at this, read that statement again, read it twice, thrice. It will make sense. Power to which base must be raised to get the number is known as logarithm of a number. Okay, to get the number. So I am raising base to some power to get the number for which I am trying to find the log. That is called as logarithm of a number. Okay, and if you will look at this number, this big number is same as that exponential number, 10 to the power 25. I'll tell you that how we are reaching from 10 to the power 25 to 25. Okay, that is coming next now. So is this thing clear? I'm not expecting that it should be 100% clear because it will take some time for you to accept it. Give yourself that time, it's okay. Okay, so x is equal to a to the power y. How it is written? Just try to understand the process. So what is the process? This is the base. This will be raised to the power of this number to get the actual number for which I am finding logarithm. So x is equal to base raised to the power. Okay.
So, sir, in this like y equals log ax, what is y? Like
Y is value of a log.
okay,
Okay.
and then
Y is
x is
value of a log, and when you are raising that base to the value, you will get back the number.
okay.
Okay. Now, when I'm using the word get back the number means what? I'm getting something back from where I started. Are you understanding this? Okay, from the statements only you can make out. That is why this process is called as anti-logarithm. Okay. Indirectly, I have taught you what is anti-logarithm also. X is equal to a to the power y is called as anti-logarithm. Now, when we will
Just a question, sir. So I have understood this concept because we did it in school once also. But what I didn't understand is how you explain that, like say 10 raised to power of 25 can be stored easily by writing log 25, right? So in that example,
not
how does log
25, log 10 to the
then?
power 25.
Yeah, but that will mean logs without anything will obviously mean log 10, right? In the bottom.
Huh.
So log to base 10 raised to power 25, but then how will it be 10 raised to power 25? That one. Can you explain with the rest of
Just
that?
wait for 2 more minutes. Okay, I'm coming on to that.
Okay, sir.
Okay,
Yes,
Sir,
sir.
I will end this
so you told
lecture
me,
with that only. Yes, medicine.
Okay,
you
sir.
told me to remind you like 5 minutes earlier
Yeah.
for that question.
Let me complete this, then we will look at your question.
Yeah, I know, sir. Just a reminder.
Yeah. It's good that you reminded. So this is called as anti-log. Okay. Now let us talk about some properties of log. Okay, with which you will understand that example. These properties of log are relatable to the properties of exponents which you have done in lower grades. Okay. So one of the property of log is when it is log m raised to the power n, base can be any. Okay, then it will be n log m. Okay, base can be any. Then when we have log of a number to the same base, it is 1. There are other properties also. I'm not telling them now. Okay, right now these two will be used. So let us just look at that example now. Okay, just keep it as a reference to understand that example. If I am writing y is equal to log of 10 to the power 25 to the base 10. Now first thing is that I have created the machine, so I have all powers to decide the base of the log. Do you agree on that? From the user, I have to just take this input. So user don't have to worry about the base of the log. That is a part of developer. Okay. So the base of this log will be 10. Next thing, if I just use these properties of log, then you can see that this 25 will come in front. Okay, I'm just telling you that how computer will finally use the properties of log, and it will get a value and it will store that value. So when this thing is written or this thing is inserted in the computer, it will solve it and it will be 25 log 10 to the base 10. Now log 10 to the base 10 will be 1. So ultimately the value will be 25. So y is equal to 25 means computer has to store only 25. Is that clear?
Okay, so now I got it.
Okay.
So you were talking about log base 10 to 25. This was 10 again raised to the power 25, right? That's what you meant, right?
The example which I took was this only, na? 10 raised to the power 25. I told this thing only
Yes,
that
sir.
if 10 raised to the power 25 is inserted by the user, then it will be stored in the machine as 25.
Yes, sir.
So that is what you can see over here.
Yes.
That if 10 raised to the power 25 is
Yes, sir.
inserted, then it is stored as 25. Okay. So this is the real power of log.
Yes,
Okay.
sir.
Right now you may not understand that. You have to just take it like a chapter, one more chapter. Okay. But it is interesting if you take it like this. Otherwise, it is a bit chaotic, boring, and scary. Many students don't
Yeah.
like it. Okay.
Yes, sir.
So the graphical part of log, we are going to continue in the next lecture. Okay.
Okay.
And yes, Madison.
Wait, sir, can I ask a question about logs quickly?
Yes.
So basically, just to like clarify, when we like, for example, when you put in 25 raised, 10 to the power 25,
Yes.
the program has programmed it to save it as 25 by putting the log value
Yeah. By putting the log function.
function. Sorry, yeah.
Okay. Because the computer will literally store this
Okay.
25 times. Okay. So just imagine it will be stored in the computer memory like this. Okay. If you apply log, it will be stored as 25. Okay. And when the user has to retrieve back the value, you have to just put an anti-log function. Okay.
Okay.
So the user will get back the same value. So what is happening in background and behind in your computer, you don't care about that. All you need is you press the button, you should see the same result. Okay.
Yeah.
Background process are like, they are not at all important for us. Okay. So that is where these things, these mathematical functions are used, and these are used everywhere. Okay, whatever apps, whatever softwares, programs we are seeing around us, all mathematical functions you can find in them. Okay. Okay,
All right.
madam.
Yeah.
Out.
So he posted a photo on the WhatsApp group.
Okay.
Yeah, so I put on the
Okay. So pound A is to be invested in a savings fund at a rate of 4%. Okay. How much should be invested so that the fund is worth 10,000 in 5 years? Okay, so this is a question of compound interest. Okay, how much will it be worth after 10 years? Okay, so that we can do later. The point is, it is not even compound interest, because they are saying that it is to be invested in a savings fund at a rate of 4%.
So this was in sequences and series. We got this question.
Okay. This will be done by compound interest only. Okay, how? Let us understand. So let's say the amount is A, which you are investing today. Okay, in 1 year, how much return you are going to get on that? That will be A times of 1 plus 4 by 100 to the power 1. That will be the return which you are going to get in 1 year. Do you understand? Okay.
Is that using the formula, sir?
Yeah, A
The
is equal to P 1 plus R by 100 to the power n. Do you remember this formula?
Yes, sir.
Okay, so I'm just using exactly the same formula. Okay, now though it is given in sequences, but we can apply this formula and do it directly. Okay, because what they have done, they have given me the amount which I need after 5 years. So I can say that A 1 plus 4 by 100 to the power 5 is equal to 10,000. That's it. If I will write it down like this, then it is just calculation part left now.
Oh, yeah.
Okay, and if you want to see that which type of sequence is this, so this is a question of geometric sequence. Okay, because when you will solve this, now it is 1.04 to the power something. So A is a fixed value. Like in a geometric sequence, what was that? It was AR square, and so on. So A is a fixed value which is being multiplied by a certain multiplier. So in the first year, this A is multiplied with 1.04. In the second year, this A is multiplied with 1.04 square. Likewise, in the fifth year, this will be multiplied with 1.04 to the power 5, and that will give you 10,000. That is what is given in the question. Clear? Is it clear or not?
Yes, sir. Yeah.
So now
Thank
can you
you.
calculate after this?
Yeah.
Like you have to just do this in the calculator. 10,000 divided by 1.04 to the power 5 is equal to A. That will give you the first answer. And next they are saying 10 years. So to get that, first you need to get the value of A, which you will find over here. And then later on, you will use it for 10 years. So 10 years, what you will do? You will just do A 1 plus 4 by 100 to the power 10. Okay, the A value you have already obtained, so you can put it over here, and then you will get the amount which you will get after 10 years. Clear?
Yes, sir.
Is there any other question?
No, sir.
Okay. Okay, so see you tomorrow for physics. Tomorrow's timing is
7 to 8, right?
yes 7:15 to 8:15.
So can I just ask what we're gonna do tomorrow for physics?
Yeah, tomorrow we'll continue with that chapter only, units and dimensions.
Okay, so because we started like we're doing uncertainties and like calculating.
Yes, sir, even us. And my question is from there only. So if, yeah.
Yeah, same. So it's so annoying though. I don't get it. Like
Yeah.
So
Can
look,
we
because
get away there only, sir? Like then we can go back to measurement if it's okay with everyone.
look,
Like, yeah.
we have started errors. I think we have done some type of errors also, have we? Or not?
yeah, we did. No, we didn't do. I think no, we
So
didn't.
we haven't stopped.
So we'll do one thing. Tomorrow we'll directly start from errors. Okay.
Okay.
There will be few different types of errors which we'll discuss initially, and then we'll move on to those calculation uncertainties.
Okay.
Okay. Just to relieve you from that, right now I can say only one thing, that uncertainty is same as percentage calculation. Okay.
Okay.
If it has
Makes
given you
sense.
some curiosity, try to keep it till tomorrow. Okay.
Mm.
If you know percentage calculation, all the things which we'll do tomorrow will be very easy for you.
Okay.